So let's go into the structure of water. What does that look like? We know that water, when it's going to form ice, it's going to start forming a structure where it's got a lattice honeycomb effect. Okay, what happens is the molecules arrange themselves in such a way that it creates a uniform pattern. And that uniform pattern, we know, then creates the structure of water, which then creates ice. Now, we typically understood that as only occurring in ice. We didn't think it happens in fluid water at all.
Yeah, it was just chemistry.
Very fluid, little molecules bouncing around. We call it Brownian motion. That's how we understand it. But in biophysics, we started noticing that water did structure itself around surfaces. So what happens? Water, it forms a structure just on the surface. And very close to the surface, we have a very strong negative charge. And this is where our honeycomb effect is.
On water-loving surfaces.
On water-loving surfaces.
What is a surface that is not water-loving?
It's called hydrophobic. It's your fatties.
Oh, the repel action.
And water does actually structure itself in a particular way around those surfaces too. And we know from biochemistry what kind of energy levels we have to put in to break that up. It's very important for the organization that we have in our cells. So we saw one part of the story. Actually, now Pollock is showing us another part of the story that's helping us then understand what we could be expecting in our physiology because of this actual phenomena that it's actually occurring. So it's opening up a door for us to go into. And I think this field's going to expand. So this is important. So how does this relate to structure of water?
And memory of water.
And sorry, you're right. I meant to say memory. So it kind of gives us an understanding, wow, with the structure now we can start having a memory. Why? Because part of memory, part of information is this ability for something like a structure to hold it itself stably over time. But also these honeycomb structures are very able to give off light and receive light. So now we can start understanding if we are throwing EM fields or if we're throwing light, we're going to get an effect. And we actually do know that if we produce infrared light and shine it on with the water on the surface, we actually are going to enhance that structure. So that's very interesting because we are heat, 37 degrees Celsius, we are infrared, we're forever emitting this. And we have seen with infrared therapy certain results that we can get with patients. Now with Pollock's work, we are able to start understanding some of the phenomena that we're seeing with infrared.
Right.
But it's also fascinating for myself is that honeycomb structure has a way of also absorbing light at a very particular frequency. It's in the UV blue light range. Very interesting. That too is then becoming a giver and receiver of information. So this is opening a door.
But how can, yes, because if water receives light and then emits light, it had to retain it.
And it's exchanging information by doing so, yes. So now we're getting
into
I'm
smiling.
Yeah, it's getting to an interesting area. And this is why we often see when we have phenolic compounds, when we consume them, we forget that we could be actually absorbing light in our bodies. And that could become an exchange for water. And it's something I have been looking into with carcinogens.